So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing binary search. And today we'll do question from search in a 2D matrix pattern, and today we'll do the another question which is search a 2D matrix too. So let's read the problem statement. Write an efficient algorithm that searches for a value target in an m cross n integer matrix. Okay, our task is to find a target value, and this matrix has the following properties. Let's read the property. It says integer in each row are sorted in ascending order from left to right. Okay, means it is row wise sorted, and integer in each column are sorted in ascending order from top to bottom. Okay, so it is column wise sorted also, row wise sorted also, but row wise from left to right and column wise from top to down. Okay, so if you'll see example number 1, we have been given a 2D matrix, row wise sorted and column wise sorted, and we have to find target 5 here. So definitely we can find, and whenever a sorted matrix or sorted array has been given, we always think about binary search, correct? Let's read the constraint first. Constraint says ki m and n can be rows and columns, and m and n can go till 300. Okay, 300 means if m cross n, if you are thinking to apply the linear search algorithm here, so definitely it will be 300 cross 300 means 9 cross 10 power 4. Obviously it will get submitted, it won't give you TLE. How I decided this? Because I know ki beyond 10 power 8, sometimes in 10 power 7 also, but mostly if your case is simple, if your conditions are simple, till 10 power 8 it is safer, and beyond that it might give us TLE. So on a safer side, until your constraints are up to 10 power 7 to 8, you can think of linear approach. But as here the question itself mentions ki write an efficient algorithm, it means ki it is expecting us the binary search solution. So let's come here on the screen. Here is our matrix, and we have to look for 5. Let's see if we can apply the binary search logic here or not. If you remember, search in a 2D matrix 1 problem which we have solved it just above this question. There, along with this 2 information, 1 extra information was given. And what was that? Ki every first value of the given row, of any row, will be greater than the last value of the previous row. Why? Because if this is 2, this must be 1, because that guarantees ki any number which is greater than this one cannot lie in this row or anything towards upward. But here this information has not been given, means if you want to check any number with 2, okay, and if you are thinking ki, suppose if you have to search for 4 here, you will definitely compare with this last element. Why? Because we have already discussed in the previous video, again saying we can either compare with the first element values, or with we can either compare with the last. Anything will work, but if you are comparing with last, like first value of the rows now, suppose 2, okay, and if you want to search ki where is my 1, so you can say if 2 is greater than the number you are looking for, then definitely that one the number will be towards the upside. But in that case where it guarantees ki this 2 will be greater than the last value of the previous row, but here it is, so you cannot apply binary search logic. The reason is, suppose you are looking for 4, so 2 will say yes, 4 is greater than, so 2 will say ki yes, 4 can be in my row or anything towards downside, correct? So yes, but if you look for 4 here towards the downward, you won't find, na, because 4 was sitting here. So hence it does not follow our binary search rule. And one more point I have talked in previous video, that was if you will open this, na, row wise also you can open, or else you can open column wise, okay? Whatever way if you will open it, if you found it is in sorted order, then you can think of applying binary search. But here if you will open this now, suppose you open 1, 4, 7, 11, 15, correct? After that 2, 5, 8, this is not in sorted order. How I open this? Row wise. Now let's open column wise. So definitely we'll write 1, 2, 3, 10, 18, means I am writing this way. Now I have to write this, means I will write 4, 5, but see, again not sorted. Yes, so can I say it is neither column wise sorted when I opened this, okay, and nor row wise sorted. So hence the binary search formula or the logic which we have applied in the previous question, previous matrix, we cannot apply it here. And remember, this type of questions are mostly been asked in the interview to check if you would have learned the code or if you have actually understood the logic here. Okay, so if not linear, not binary search, then what can we apply? If the sorted information is given, definitely we can use it, but we cannot apply binary search. Let's see what can we do. If I am standing at here 1, can I say ki suppose I want a target 3, okay, target 3. So I can decide now ki yes, 3 is greater than 1. So where should we go? Because I know greater number can be here downwards also and towards right side also, because it is sorted in that way. Yes. So hence if I am standing at 1 now, I cannot decide ki where should I go, towards right side or towards downwards. Yes. So means I cannot start from this corner. Can I start from this number? Can I start again? If I'll start from this number, I want suppose 7. Okay. So still 7 is greater than 4. Don't think okay 7 is here, return it. Think from the code perspective ki how this 4 will decide ki we have to go towards the downside or right side, because in both the directions you have the greater elements. So hence you cannot decide here also. 7, you cannot decide. 11, you cannot decide. 15, let's think. If the number is greater, okay, I can go down, and if the number is smaller, I can go left. Yes, I can go. Means I have 2 paths, one for the greater one and one for the smaller ones. Okay, now suppose what you were looking for, you were looking for target 7. Okay, no, target 4, correct? Yes. So you are standing at 15. You can say what are you looking for? Target 4. Okay, it is lesser than 15. So why not to go towards left side? Why I have said this? Because I had 2 paths and I can choose only one path when I am greater than or when I am smaller than my target element. So when I am greater than target element, I can say I need to reduce myself, and definitely I have to go towards left side, because if I will go towards downward, I will find more number, like greater than, I will find greater number than me. So hence I have to move towards the left side. Now I am standing at 11. I can ask ki hey, what is the target value? It is still lesser than me. Means I have to go towards the left side. So basically, if I am standing at the very last, suppose I will have a row and column when I am standing at a matrix, correct? Yes. So I am saying go towards left side. So am I changing the row? No, I am not. So what I am changing? I am changing the column. So basically whatever you have thought, let's write it. I said ki if my matrix of row column is greater than what? Target. Is greater than target. What we decided? We will do column minus equal to 1. Means we will just reduce the column. Okay. Now we are at 11. Okay. Still lesser. Reduce the column. Now we are at 7. Still. Now we are at 4. So can I say target and number matched? Yes. So what I will do? Can I write here one more case? Ki if my matrix of row column equal to target, correct? Yes. So can I say what I have to return? We have to return true or false. Okay. So I can say return true. Yes or no? Yes. I can say return true. Yes. Okay. Now suppose we have to look for 5 here. So now you are at 4. So you will see ki your target is 5 and your current element is, so you know when you want greater number, you cannot go left, because when you want lesser number, you decided to move towards left, na? Because every number is sorted, correct? So now definitely you would like to go downwards, and for downwards, are you changing your column? No, you're not. You're moving in the same column, na? But you are definitely changing your row. And how you are changing the row? Row minus or row plus? You were at 4, now you want to go towards down. Definitely row plus. So when you will increase your row. So can I say ki if my matrix of row, column is lesser than target, correct? Then what I would like to do? Row plus equal to 1. Okay guys, so we are moving, like we are incrementing the rows and we are decrementing the column. So definitely they might touch their boundaries. So how the row can touch their boundary? By the last row. correct? And how column can touch the boundary? Because it is moving towards left side, so it means column might be negative at some point. So basically we have to close all this in a while loop. What? While my r is less than rows, that rows we will calculate, correct? And along with that, I want my column to be greater than equal to 0. Then only we can perform this. If somehow we have not found any equal to value, so definitely either R or C will go out of boundary. How? Let's see. Suppose you want to find target 0. So definitely you will start with 15. Target 0, 15. Then it is greater, so you will move towards left side. Again 11, greater, you will move towards left side. Again move towards left side. Again move towards left side. Now you are at 1. Still you want lesser number. So definitely you to will do na C minus is equal to 1. So yes, you did. But when you will go here, while loop will check ki no, now the C is not positive. Now you are out of boundary. But wait, after this, as you have written this in if case, say, so it might check. So hence you have to put this in a else if condition. Why I said? Because suppose C is out of range. So after this if condition, it might check another if. If you will put in else if k condition, so on any of this one if case will pass, correct? And the last one you can put in the else condition, correct? Else. So now I have just written this condition to show you ki when it will fall, but you can definitely mention this in a simple else condition, okay? And now because C is out of the range, so while loop will stop, and definitely we can say after coming out the while loop ki yes, we have not found our answer because 0 is not present here. So hence we can simply, like after coming out, we can simply return false. Yes or no? Yes. So we want to calculate rows and columns. So let's say rows equal to m, and that we will calculate by matrix dot length, correct? And column, let's say n, which is matrix of 0 dot length, correct? Now as you remember, we started from the top right corner, right? So top right, in top right definitely my row will be 0 and my column will be what? Think again. My column will be definitely n minus 1. Yes. Now I want to start my while loop until my row is less than what? M, and until my column is greater than equal to 0. Yes. Now I have to check if my matrix of row and column is equal to target. What if my target, like it's equal only? Then definitely I'll simply return true here, correct? Yes. Else if I have to check now ki if my matrix of row and column, yes, if it is greater than my target, suppose if it is greater than my target, so if here we saw na ki when I was suppose here, okay, so if it is greater than my target, so definitely I want a lesser number, so I will go towards left side, so I will decrease my column here, correct? Yes. And in else case we will simply do r plus is equal to 1, means increase the row here. Now after coming out of this while loop, I can simply say ki return false if nothing has been returned, means we have not found the valid answer there. So now it has been passed. Now let's try to submit this, and it has been submitted. So here was your Java solution, and here is your Python solution if you are from Python background with the same logic, and here is your C++ solution if you are from C++ background. Now let's discuss the time complexity. As you can see, we have not applied the binary search here, correct? Yes. So definitely we have not decided ki which part we will choose, like either the left half or the right half or upward or downward. So definitely it won't be logarithmic time complexity. But what will be the worst case time complexity? If you will see here, suppose your number is 1, okay? So let's see how many like time you have taken. Can I say that is nothing but number of column traverses you did for this? Yes. Now suppose 30 you want. So in case of 30, definitely you will look for the larger number. So you will keep on going down, 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 and you will travel number of rows. Yes. Now suppose you want 18. Think again. You want 18. So from 15, you will say ki 18 is maximum. So we want a greater number. So you will go here. Now 19 is more. So you will say ki no, I want a smaller number. So you will go towards the left side. So you will move to 12. Now again 12 is smaller. You want a greater number. So you will move towards downward. Now what? Now again you will say ki 16 is lesser. So you want greater number. So again you will move downwards. Again 17 is lesser, move downwards. And now you will say ki yes, it is more. So I want smaller, so you will go left, and now you will find. So how many iterations you did? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total iterations 9. And what was the number of rows and column here? 5 plus 5. So basically this time complexity is nothing but number of rows and number of columns in the worst case, because we just saw either number of rows or number of column, or in the worst case you will travel everything. Why it is not exactly 10? Because you travel all of this and you travel all of this. So this part though you have traveled only one time na, but you are counting this 2 times in number of columns also and in number of rows also. So hence in the worst case the time complexity will be O of m plus n, and this approach is called staircase approach. Remember that this is not linear approach, this is staircase, because this is how you are traveling here, correct? Now the next very important question which might be asked in the interview is ki why you have chosen this this index only to travel. I just showed you cannot start from here, because if you start from here, how you will decide ki whether to move when you have a greater number? Yes. Similarly, you have not found all for this. Now for 15 you were able to decide. Now let's try to find for 24. Can I find for this 24 or let's suppose 19? No. You have 3 different directions to go na. Don't choose that. Choose only that index or that cell from where only 2 directions are open. Means you can decide na ki for greater where to go and for lesser where to go. So if you will find that type of index, so definitely these cells will have 3 opens, correct? 3 directions. We cannot choose that. So hence these are neglected. Yes. Now anything in between if you choose, they have 4 directions now, correct? So hence nothing in between you can choose. So what all options you are left with? 1, 15, 30 and 18. For 1 you just saw ki rightwards and downwards both were greater. We cannot decide ki when where to move when we have lesser number. Yes. For 15 we were able to decide. Now let's see for 30. For 30, upward also are lesser numbers and leftwards also are lesser number. Means where to move when we want a greater number. So hence we cannot start with this index also. Can we start with this cell? Okay. When we want a smaller number, we can go towards upside, and when we want a greater number, we can go towards right side. Yes, we can. So hence the valid cells from where you can start this staircase approach are top right corner or bottom left corner. And this is the proof key why I have started from this. I could have started from this also, and that is the task for you guys. Try submitting that and let me know in the comment section if you have submitted or not. So with this we can go in our sheet and we can mark the next question as to be submitted. I hope you guys understood with the time complexity and what path to choose on our own. And I hope you remember this in interview as well. And if you found this video really helpful, then it is my humble request to please like the video and subscribe the channel. And if you feel these videos can be helpful for your friends also, then don't hesitate to share with them. And if you guys are new to this channel, we are following the pattern-wise DSA sheet. The sheet link and all of my social media links you will get from the description. And that's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.